Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, we will be looking at Fast Track for CUSAT-CAT. Now, the Cochin University of Science and Technology is a federal university in India, and it is regarded as a pit stop for people to pursue a career on science and technology. Now, the institution established the Common Admission Test, or CAT, for people who want to enter into CUSAT. Although the exam is rigorous, like any other exam, it can be tackled with the right amount of preparation. And that's what we're going to be doing for this video. Now, we will be looking at previous year questions of CAT, the reason being that using those questions we'll be able to understand how questions can be asked for this year and for the years to come. So today we're going to be looking at some questions from chemistry. Here comes our first question. In an acidic medium, zinc reduces nitrate ion to ammonium ion according to the reaction. Zn plus NO3 minus gives Zn2 plus NH4 plus H2O. Remember, the equation is unbalanced. How many moles of HCl are required to reduce half a mole of NaNO3 completely? Assume availability of sufficient zinc. So, how exactly are we going to solve this question? Well, the question here demands us to balance the equation. And then we use the source of hydrogen as HCl. And then finding out the required, well, what do we call it? Finding out how many moles of HCl are required for 1 mole of NO3 minus will give us how to solve this question. So, the first step to balancing an ionic equation is to form half equations. So, zinc forming Zn2 plus can be considered as one reaction, and NO3 minus forming NH4 plus H2O is another half equation. Now remember, Zn loses 2 electrons to form Zn2 plus, and nitrogen gains 8 electrons and loses its oxygen to gain hydrogen to form NH4 plus. So, the next step is to add water to what we call it, to adjust O2 deficiency. Now, in the first half equation, Zn forms Zn2 plus. There is no requirement for change in oxygen, because there is no oxygen deficiency in the first place. However, on this end, the second half equation, 3 oxygen atoms are lost to form NH4 plus. However, they're not replenished in the unbalanced equation. So to balance that, we write on the right hand side NH4 plus 3 H2O. Let's write it down. So 3 times water plus NH4 plus is the result from NO3 minus. Now remember, again, we're still unbalanced because the hydrogen part is still not balanced. So what we do is we count the number of hydrogens on the right hand side. So we have 4 hydrogen atoms in NH4 plus and 6 hydrogen atoms in 3 molecules of water. So overall we need 10 H plus. So what we do is we add 10 H plus to the left hand side. So NO3 minus plus 10 H plus gives NH4 plus 3 H2O. Again, both sides of the half equation are balanced. Now the next step number 3, give me a minute. Step number 3 demands us to add the number of electrons on both sides. Now, on the first half equation, Zn loses 2 electrons to get Zn2 plus. So we add 2 electrons on the right-hand side. Let's put that in a bracket. Now, the next equation will have NO3 minus plus 10H plus on the left-hand side. And that gives us NH4 plus 3H2O on the right-hand side. Now, water does not have any ions, any permanent ions in it, so therefore it's neutral. However, we do have a positive charge here. Now, 10H plus means that we have lost 10 electrons. On the other hand, O3 minus means that we've gained an electron. So we have a total displacement of 9 electrons here. So if we add 8 electrons, we would still have the deficiency of 1 electron. So that will be represented by a +1 charge. So 8 electrons would be the correct amount of electrons to be added on the left-hand side. Now, if we look at the two half equations, in half equation number 2, we have 8 electrons. In half equation number 1, we have 4 electrons. In order to balance the number of electrons on both sides of the equation, we multiply the first half equation by 4. So now the ionic equation that we get is 4Zn plus NO3 minus plus 10H plus gives, let's write the other one first, 4Zn plus, 4Zn2 plus NH4 plus 3H2O. So the 8 electrons on the right-hand side cancel out the 8 electrons on the left-hand side, so we just have a pure ionic equation. But this time, this equation is balanced in terms of ions. So we are checking out and balancing ions in an equation. So the NO3 minus ion can come from any source. So we can take NaNO3 as a source here, because sodium has a +1 charge, NO3 has a charge of -1. So that's the source. But what about the source of hydrogen? We can use HCl as a source here. So if the hydrogen source is HCl, then the reaction would become 4Zn plus NO3 minus plus 10 times HCl. Instead of H plus, we put in HCl. So in order to balance out the 10 chlorine atoms that came in on the left-hand side, what we do is we write 4Zn2 plus NH4 plus 3H2O plus 5Cl2. So we take 5 chlorine molecules we get 5 chlorine molecules on the right-hand side that came over from the 10 chlorine atoms. So from this particular equation, we can deduce that 1 mole of NaNO3 requires 10 HCl. So if we look at the equation, requires 10 moles of HCl to be reduced. So therefore, if we have half mole of NaNO3, in order to reduce that, we need 10 divided by 2 moles of HCl, which is equal to 5 moles of HCl. So therefore, 5 moles of HCl would be the correct option. That means option A is the right one. Now remember, why did not we calculate Zn into the picture? That can be answered by the question. The question says, assume availability of sufficient zinc. So the number of zinc will be adjusted in order to get the relation between NaNO3 and HCl. So you'll have the required amount of Zn no matter what. It will not act as a limiting reagent. Now, let's look at another question. The electrons identified by quantum numbers n and l, we have 5 electrons. So the first one is n equals 3, l equals 2. The second one is n equals 5, l equals 0. The third one is n equals 4, l equals 1. The fourth one is n equals 4, l equals 2. And the fifth one is n equals 4, l equals 0. Now these 5 electrons can be placed in order of increasing energy as 1 less than 5 less than 3 less than 4 less than 2. That's option A. 1 less than 5 less than 3 less than 2 less than 4. That's option B. 5 less than 1 less than 3 less than 2 less than 4. That's option C. 5 less than 1 less than 2 less than 3 less than 4. That's option D. So, how do we solve this question? Well, for that, we need to understand how are quantum numbers related to energy. Well, for an electron, if you have a higher value of n plus l, which means the sum of the principal and azimuthal quantum numbers, that translates to higher energy. So the electrons here, which have the maximum number of n plus l, would give you the maximum amount of energy. So if we look at electron number 1, the addition of 3 plus 2 gives you 5. For option 2, it's still 5 because it's 5 plus 0. For option 3, it's 5 because it's 4 plus 1. For option 4, however, it's 6 because it's 4 plus 2. And for option 5, for electron 5, it's 4 because it's just 4 plus 0. So as you can see, the least amount of energy is with electron number 5, and the highest amount of energy is with electron number 4. But now we have a problem. In our options, every electron is greater than its previous electron. But over here, the n plus l value of 3 electrons are the same. So how do we solve that? Well, for any electron which have the same n plus l value, the higher value of n translates to higher energy. Higher value of the principal quantum number gives higher energy. So that technically means if you're in the outermost if the electron is in the outermost orbit, then it will have the maximum amount of energy. So if you were to use this law, then you can see that 2 has the maximum amount of n, which is 5, followed by 3, which has n equals 4, and then finally we have 1, which is n equals 3. So electron number 5 has the smallest amount of energy, and then so let's write it down. 5 has the smallest amount of energy, and then we have 3 electrons with n plus l value equals 5. So among them, electron number 1 would be the smallest because, well, n equals 3 on this one. Electron number 3 would have the next highest amount of energy because, well, n equals 4. Electron number 2 will have the highest amount of energy among the 3 electrons with same n plus l value because its principal quantum number is 5. And then we have electron number 4, which has the highest amount of energy over the given set of electrons because its n plus l value is equal to 6, which is the highest amount. So the correct order is 5 less than 1, less than 3, less than 2, less than 4. And this particular order is found in option C. So option C becomes the correct option when it comes to identifying the order of electrons placed in terms of increasing energy. The other options are incorrect. A and B are incorrect because they say that 1 is less than 5, whereas in fact 1 has a higher n plus l value. And option D is incorrect because it says 2 is less than 3, whereas 2 has the higher value of the principal quantum number, so that is incorrect. The only correct option among the following is option C, 5 less than 1, less than 3, less than 2, less than 4. Now let's look at the final question of this episode. We have the number of photons emitted per second, but we need to find out the number of photons emitted per second by a 60-watt source of monochromatic light of wavelength 663 nanometers. We also have the value of h, which is Planck's constant. Now, for this, we need to use the photoelectric effect. Now, in the photoelectric effect, the base value of energy equals h times nu. So therefore, if you need to find the number of photons, then E will be equal to n times h nu. So n times the energy of one photon. Now, how do we find out the number of photons? Well, for that, we need to know the energy, we need to know the frequency. Of course, you can calculate frequency as c over lambda, where c is the speed of light, which is constant, and lambda is the wavelength, which again is given. So now we know the wavelength, we know the Planck's constant, we also know the speed of light, which is constant, but we need to find out the energy in order to calculate n. So how do we do that? Well, let's look at 60 watts. Well, 60 watts here represents the power. Now, power is defined as energy over time. So 60 watts essentially is 60 joules emitted in 1 second. And since we're finding out the number of photons emitted per second, the value of energy will be 60 joules. And then we know that h equals 6.63 into 10 raised to minus 34 joules second. This is h, not n. We have the value of c, that's always the same, which is 3 into 10 raised to 8 meters per second. And we also have the value of the wavelength, lambda, which is 663 nanometers, which can be calculated as 663 into 10 raised to minus 9 meters, which can further be shortened into 6.63 into 10 raised to minus 7 meters. Now, let's use the formula energy of n equals n times hc by lambda. So this is the formula of the photoelectric effect. Now, let's plug in the values. En is 60, n is still unknown. However, we know h as 6.63 into 10 raised to minus 34 times the speed of light is 3 into 10 raised to 8, and divide that by the wavelength, which is 6.63 into 10 raised to minus 7. Now, let's take the variable on one side of the equation and everything else on the other side. So if we take n by itself on one side, on the other side we'll have 60 times the denominator in the previous case, which would be 6.63 into 10 raised to minus 7. We divide that by the whole numerator, except n, of course, which is 6.63 into 10 raised to minus 34 times 3 into 10 raised to 8. Now we have values of, now we have 6.63 both in the numerator and denominator, so they cancel each other out. When you divide 60 by 3, you get 20. So therefore, you get a total of 20 times 10 raised to. 10 raised to minus 4 in the denominator. When you take it up to the numerator, it becomes plus 34. 10 raised to 8 in the denominator. When you take it up to the numerator, it becomes 10 raised to minus 8. So it's 10 raised to 34 minus 8 minus 7, which is equal to 20 times 10 raised to 34 minus 15. So 34 minus 15. 14 minus 5 gives you 9. 2 minus 1 gives you 1. So the value of n would be equal to 20 into 10 raised to minus 19, which we can further simplify as 2 into 10 raised to, it's not minus 19, by the way, it's plus 19. So the number of photons equals 20 into 10 raised to 19, which is the same value as 2 into 10 raised to 20. So 2 into 10 raised to 20 is the number of photons emitted per second by a 60-watt source of monochromatic light with a wavelength of 663 nanometers. So therefore, option D is the correct option among the following. Option C is incorrect because it says 3. Options A and B are incorrect because, again, it says 4 and 1.5, which is wrong. The right option, according to the calculations, is option D, 2 into 10 raised to 20. So in order to calculate that, we have to make sure that we use the photoelectric effect formula. The base formula is E equals h nu. That's for one photon, energy of a photon. If you want to find energy of n photons, then you multiply n to h times nu, which is hc by lambda. So that concludes this episode of CUSAT-CAT Fast Track. If you want to access more of our resources regarding CUSAT or other exams, then please visit our YouTube channel, www.youtube.com. At www.youtube.com, the name is Agile Rank Mate. And if you want to get updates about our content, then please don't forget to subscribe and press the notifications icon present below the video. Also, if you've liked the content, then please share your thoughts in the comment section down below. So, until the next episode, this is ARM. Take care, stay safe, bye-bye for now.